welcome to my talk. I will talk about Kubernetes at the edge with Needs OS. So a little bit about me. This talk started out of curiosity, basically, because as all we know, the containers are reproducible by nature. But this is not the whole truth for the cluster. I would like that, what if the host, the workloads, even the recovery process was reproducible too, or behaves in the same consistent way? And then that was the question, why this matters. So at the edge, we have that Kubernetes is really good in stateless, in reproducible, our images, our apps, but it's not so good when it fails long before the containers starts. What is the meaning of this? I'm not saying that the image doesn't matter, that the container doesn't matter, no matter. They do, but it's only a part of the story, it's only a part of the system. We need to consider the host, the cluster, the workload, all together. What if this was declarative? We can declare this in our system and behaves consistently and in a way that we can reproduce out of scratch. So this is particularly true on the edge systems and the edge environments where our hardware is constrained. Maybe the hardware, it's physically constrained. We don't have access to the servers. That's usually what happens. We have unreliable networks. Depends on the region. Maybe we don't manage those networks. We didn't configure those networks. We have awkward remote access. Maybe some security constraints there. We don't have the SSH access. We may need a VPN to access, or a joint server, a Bastion server, to access to our cluster. So in several cases, this would require manual operations, manual operators, in which the state in which the manual operation occurs versus the declarative status occurs, generates a drift. So even if you are a sole operator of these clusters, it generates a tribal knowledge. And you can't plan on recovery on this tribal knowledge, basically. So what's the tools that we try to solve these issues? The tools that we usually use are maybe Ansible. You can use Ansible perfectly. Maybe you can use Packer. You're familiar with Packer or tools similar tools in which you generate golden images to help to solve the problem. You may use, again, manual operations, qdadm, qcuddle, to fix, let's say, an SSH failure, a firewall issue, a port, but all this does not solve the problem. All this generates more technical debt or what I call a snowflake effect. The solutions here, don't get me wrong, the tools are excellent, but they don't fit the problem, basically. So what do I have in mind in this case? I have in mind that I wanted to declare the configuration. I wanted to take into account the Kubernetes distribution, the workload, the deployment process, and even the backup and the recovery process that I have. I didn't have several tools to manage this series of steps, and I don't want to depend on my memory, even on my home lab. So the stack that comes to my mind that generates in the architecture was NeetsOS, which is a Linux operating system that allows me to generate a contract in a file in which I can declare instructions of how my system will behave. The distribution that I picked in this case was K3s, a lightweight Kubernetes distribution for control plane, Colmena for the deployments, Terramate and Terraform for the architecture and provisioning, and for Yahoo Raspberry Pi, and again using NeetsOS to run on my mini runner, the workflows on my Mac mini runner. The workload, because I want to use this as daily as possible, I wanted to scale, so I picked something that I would use. In this case, it was the app RosDesk, which allows me to connect to my servers. So I test this on my Raspberry clusters, and then I move on to the cloud using the same approach. So let's talk little by little. Over the base layer, I have NeetsOS, like I said before, is a declarative Linux operating system. I will show you some snippets there and some code there. And it's really ideal because you can declare, like I said in the previous slides, you can declare the boot, the users, the firewall, all the behavior is consistent and it is in a file in which you can declare how it would behave the host. And you can reproduce the rollbacks, reproduce the behavior of the behavior in a way that you can codify this behavior. Also, you have natively, you can manage the rollbacks, which I don't know any distribution that manage in this way, but you can manage the rollbacks natively and via generation. That it's a really cool feature, and also has this feature because it has native support for K3s. So with the constraint that I have, I was able to merge basically these two seamlessly. The K3s has a long history running on Raspberry Pis, so I was very familiar with this distribution, and I was able to install it on NeetsOS, basically. So let's do like this. Okay, I have this small diagram in which I separate what is the infrastructure and what is the host. So I have a repo in which I manage with OpenTofu and Terramate all the provisioning, and I have another repo which has all the NeetsOS instructions, all the declarative way of K3s, all the workload or the workload definition. All of them connects to my GitHub, my Forgejo server, in which is installed in my Raspberry Pi. Those workflows run on my Mac Mini. Everything connects via Tailscale, so I can connect from everywhere, so in a secure way. And then, in that way, when I have a deployment or I have a promotion there, it connects to my host, then to my server, then to my workload server, and then to my client. So the directory is how this is how the repository looks like. The structure looks this way. I separate this in 3 main folders. The ads are the workloads, the hosts are the host information, the modules are the shared information that I have, and I consider this structure because it's easier for me for troubleshooting. And as you can see on the right side of the screen, basically, that is very easy to read the configuration. You can enable and disable services. Well, I have a bootstrap service that runs the first time. I have the workload, in this case ROS test, that is enabled by default. And I have a backup process that I'm using restic basically for my backups. So let's get deeper. In the workload, you can see that this is the configuration of the deployment. This is how it looks from the needs retrospective Kubernetes node, a Kubernetes deployment, in which I had set the host network, in which this parameter picks the same name as the host name. It will be picked as a namespace as the network. I would release 2 containers in a declarative way, one for the relay and the other used for ROS test as a component, and it will connect in that way. I'm connected via virtual machine because this machine has some limitations, some network limitations, so I needed to install Debian distribution or any distribution and pick up for the host server from here. So the URL, what you're seeing here, is my magic DNS. This is an alternative for GitHub, self-hosted. This is all again in a NeetsOS distribution. I'm connected from my house. I'm coming from Uruguay, so it's a long way from there. So you can see here the infra repo and the actions. It's split in 3 logical actions. I divided these in stacks using Terramate with OpenTofu. The stacks were network, storage, and compute. This is running, this is run, this was able to provision the Oracle Cloud, the Oracle cluster, successfully from here. The other repo that I have is the needs repo. You can see that I have here the Colmena, which is in charge. This is how it looks like. It's a very long log, which the activation was successful in this case. The deployment and the upgrade to the system was successfully. Another nice thing of NeetsOS is that it's atomic, the activation. What is the meaning of this? The management of the states, if any package of my system fails in the pipeline, it doesn't compromise what is already deployed. So it's deployed atomically in that way. I also have, I have it on my backups. Each time that I have a deployment, I consider a backup and a recovery process. Something that I noticed in my work is that the people generally underestimate testing the backups and the recoveries, and I did this intentionally. So I'm testing the backups and the recoveries consistently, and I was able to reproduce successfully the backup, do a recovery from scratch, and the result was pretty good. Actually, I was pretty happy with what I did at that point. So let's go back to here. So go back to here. I talk about this. Then what were the hard parts of all this? I didn't consider that the neat syntax was the hard part here. It was the fun part, really. The hard part was the architecture and the investigation behind to join the pieces. So this would require this process in the setup that I did, in the setup that I managed to work. It would require a bootstrap process because, as you well know, Oracle doesn't provide NeetsOS images. So I need to introduce some stats that I will show you in the next slide, which allowed me to install the NeetsOS distribution, basically. Also, I simplified the architecture because I was using tail scale. I didn't want a NAT server there. So a trade-off was introduce a public IP in the cluster and then leave that IP there. To manage the secrets, I didn't want the traditional way that had the GitOps approach to set the secrets in basically my GitHub or my Forjejo as an environmental var. What I did was a repo using SOTs. SOTs, it's the secrets operation the way that I managed to decrypt the secrets, encrypt and decrypt the secrets. I use a model, a needs call, SOTs needs there, and set up the status of the Terraform in my runner. This was done intentionally because I was the sole operator, but it's easy for me to change because all the focus is declarative. So, as I said, the hard part was the transition. So I will show you the bootstrap, the initial setup that I did at that point. So initially, I had to set up a bootstrap process in which enable the public IP and the SSH access to the server. I provisioned the Oracle machine, and I used something called NITSOS infet. It's not a disease, nothing like that. But basically, this allows me to convert the conversion from an Ubuntu machine to a NITSOS machine. And this is done seamlessly. So after the deployment, this will require a reboot. I need to log in as a root. Then all the magic of needs happens. This is provision, the workflow validates, the SSH, it corroborates the SSH, the services, the user is set up, and then, it's not showing here, then I run again with the new configuration, disable the bootstrap, disable the SSH because I don't need it, because I will enter with tail scale. I only leave it as a breaking glass strategy. And then I'm steady and ready to go. This is a K3s screenshot in which I corroborate via the cluster. The important part here is that the snippet code that I show you, the relays and the configuration, the two containers, is there and is alive and is in its OS. So it's operating consistently. I think this has like a month and a half, if I'm not mistaken, at that point. So let me show you. Let me see if I can connect. So here I have in my machine, I'm connected via relay. If you're familiar with Rostdesk, you have two ways to connect it. It's an open source project. It's similar to TeamViewer. So I'm connected via relay. Here, I connected to my servers, but I also connected to my phone. If I do this here, for example, I enable here. It's enable. And let's see if it connects. Okay, it's connecting. Okay, and then I'm able to connect the same way that I'm connecting to my servers. Here I can see all my servers. I can see my Oracle cluster that is running. I can see my runner, and I'm able to access easily, and more important, securely. So I will disconnect a moment. Okay. Let me disconnect. So the recovery already show you that, and then the strong fits of this. This is ideal for remote edge nodes. As I show you, for the constraints, needs is particularly strong in multiple architectures. I can deploy this consistently in any architecture that I want. The changes are minimal, are declarative. In small fleets, I put there with high discipline because I'm considering the recovery and the backup process as a rule, basically, for the deployments. What is not working this so well, if you have ephemeral environments, it's not ideal. If you have a team that doesn't like needs, it's debatable, but it might be happening because the complexity might not be justified. And then if you want a pure GitOps approach. So, sorry for I tried my best to do like a circle, but the scale was an egg. So basically, I tried to picture this in a cycle in which I introduce my code changes, and it's a very DevOps approach, because I'm not DevOps, but I'm introducing the code changes, then the push to my Forjejo, which needs of the distribution. Then the checks running there activates the runner. The runner, something that I forgot, is running needs Darwin. You can also run needs on Mac. So yeah, I can have a seamless experience in my runner too. Then the changes are promoted, in this case, for the use case that I'm staging here in my Oracle Cloud, but it might be anywhere. Then the workload is available. The validation, the backup process pipelines run, and then I can restore with confidence, let's say. The issue that I have with the former approach that was not needs OS is that 1 minute. Oh, sorry. Well, this is the last. This is the last one, and then that's it. Pretty much, there is my information there, my repos. I also create an article that deals with the configuration in that about this. You can find it here, and then that's pretty much it. Thank you.